Hello, here are the solutions to the 7.3 Day 2 homework. Again, feel free to fast forward through anything that you need and just listen to the explanations of the problems that you do and skip the stuff that you don't need. Did that make sense? Hope so. All right, so looking at number 1, this is an exterior angle, so that angle is half of its big arc minus the little arc, which would be half of the big arc is 160 minus the little arc 68. That's half of 92, which is 46. Number 2, this exterior angle, 1/2 of the big arc minus the little arc. That angle X is half of big arc 130 minus the little arc 30. Half of 100 is 50. On this piece over here, let's see, I'm going to start with this exterior angle over here. That exterior angle, half of the big arc minus the little arc. The exterior angle is 50. 1/2 big arc is 160 minus the little arc X. Multiply by 2 to clear the fractions. That's 100 equals, the 2 times this half cancels out, so that leaves us with 160 minus X. Subtract that 160. X is 60. That gives me this arc here as 60. So now I have a 60-degree arc and 160. That's 220. 360 minus 220 is 140 for that piece. So then that means angle Y is half of the 140. Y is 70. Number 4. This is an ice cream cone situation, an exterior angle formed by 2 tangents. So the exterior angle and this small arc add up to be 180. So 180 minus 120, X is 60. For this one, let's see. Angle X, it's an interior angle. So that interior angle is 1/2 of its arc plus the arc of the vertical angle. So that angle X, 1/2, its arc is 180 degrees. It hits the endpoints of the diameter there. So X is, or its arc is 180 plus now the arc of the vertical angle. That's this bit here. 1670 is 130. 180 minus 130 leaves 50 for this one. So there's the vertical angle arc. And X is 1/2 of, that's 230. And half of 230 is 115. All right, now to find Y. Oh, well, Y is this arc right in here. That's the little arc formed with this exterior angle. So if we use the exterior angle, that's going to be 1/2 of the big arc minus the little arc. That exterior angle, 53, half of its big arc, well, it hits the endpoints, the diameter, so its arc is 180. Minus that little arc, that's Y, that's what we're looking for. I'm going to multiply by 2 to clear the fraction, so 106 is 180 minus Y. Subtract that 180, and Y is 74. Okay, now this guy over here, number 6, we've got this star here. And what we see is that all of these arcs are marked congruent. And there are 5 of them in here. So 360 divided by 5 makes 72. So all of those arcs are 72. Now, if I look at y is an inscribed angle, so we know that that y is going to be half of its arc. So its arc is 72 and 72, 144, which is 72. Now, let's find x. X is an interior angle, so that angle, x, is going to be half of its arc plus arc of the vertical angle. So the angle x is half. Its arc is 72 plus, now, arc of the vertical angle. I got to follow the other sides out. And it's going to be this arc here, which is 72 plus 72, or 144. X is half of, let's see, that's 216. Half of 216 is 108. Okay. Number 7. A departing space probe sends back a picture of Earth as it crosses the plane of Earth's equator. The angle formed by the 2 tangents to the equator is, that should say 20 degrees, and they've got it in the diagram, 20 degrees here. What arc of the equator is visible to the space probe? So they're asking you to find this, the arc of the equator. This arc right here, because these guys are tangent to the globe, or tangent to the, not globe, tangent to the Earth, so, or tangent to the circle if you look at it that way. This is an ice cream cone situation. So this arc plus that angle add up to be 180. So that arc is 160 degrees. Number 8. Okay, at the left, a cross-section of a ball is a circle. How many degrees is the arc of the circle that's below the points of contact with the hands? So the hands are holding this ball right in here. I wish I had a ball close by. I would show you one, but I don't have one close by. So, but you got this ball balanced between your hands like this, and they're telling you it's 55 degrees here. They want to know what part of the circle is this. So they want to know this arc length here. Well, again, it's this ice cream cone situation. So the angle here plus the arc add up to be 180. So 180 minus 55 is 125 degrees. Okay? All right, these guys. We're going to use the circle formulas from the 7.3 day 1 and 7.3 day 2 formulas, all these formulas to find the following. So we got to look at this type of angle out here. This angle 1 is an exterior angle, which means it's 1/2 of the big arc minus the little arc. That angle 1 is half of, okay, big arc. That's this 170 minus this little arc in here. We're going to have to find that. So the 170 and the 100 is 270. 360 minus 270 is 90. So this arc right in here is 90, which means that, and we'll have 1/2 times 80, which is 40. So angle 1 is 40. Number 10, we want to find this angle 1, and that's an interior angle, so that interior angle is 1/2 of its arc plus the arc of the vertical angle. Angle 1. We're in trouble though, because its arc is right here and the vertical angle arc over here, and I don't have those. What I can do though is find this angle over here, this dotted angle. So I'm going to say the dot is 1/2 of its arc, 50, plus the arc of the vertical angle, 40. That's 1/2 of 90, which is 45. So now be careful, that's not the answer to angle 1. That's the answer to the dot. So if that angle is 45, these two form a linear pair. They add up to be 180. That leaves 135 for angle 1. Number 11. Okay, angle 1 is 30 degrees. And we have to find measure of arc AB. So this is what we're looking for out here. That's an exterior angle. And that angle is 1/2 of the big arc minus the little arc. They told us the angle is 30. Big arc, I don't know, I'm going to call it X. Little arc is 40. Multiply by 2, clear the fractions. Add the 40. X is 100, and that is what we're looking to find. So down here, arc AB is 100 degrees. I forgot my little degree symbol over here for angle 1. Okay, number 12. Let's see. We have to find angle 1. Well, it's an exterior angle, and whether you use the shortcut of an ice cream cone situation or whether you use 1/2 of big arc minus the little arc, you're still going to have to find this little section in here first. And we've got 360 in the whole circle minus 230 leaves us with 130 here. And then we know the ice cream cone situation, the 130 and this angle 1 have to add up to be 180. So angle 1 has to be 50 degrees. 13. Arc AB is what we have to find here. Let's see. I got this 80 degrees here, and I want to find that arc. I'm going to call that X. I don't have any diameters, so I can't go that route. Ooh, but I do have this interior angle of 80 degrees right here. And that angle is 1/2 of its arc plus the arc of the vertical angle. The angle 80, 1/2 its arc is 95 plus the arc of the vertical angle is X. Multiply by 2, clear the fractions. 160 is 95 plus X. Subtract off that 95, and X is 65. That is arc AB, exactly what we're looking to find. Number 14. Let's see. All right, we'll circle P. Got it. So P is the center right here. Diameter AB, got it. Measure of angle A is 68. And we have to find measure of angle B. Whew, well, we don't have any arcs in here. A couple ways I would do this. First off, I'd look at angle C. Angle C is an inscribed angle. It hits the endpoints of the diameter. So that's 180 degrees, which means angle C is 90. Then we can use the three angles in a triangle, add up to be 180, and that's going to leave 22 for B. So you could do 68 plus 90 is 158, then do 180 minus 158, and we're going to get 22. So angle B is 22. Okay, my directions for number 15 ended up on the bottom of the page here. I don't know if yours are on the bottom of the page or if they're on the top of the next page, but either way, for number 15, in Circle E, find each of the following measurements. Okay, let me set this aside. Sorry, I had to sneeze. So we are looking at finding these measurements here. Let's see. Oh, it's all the arcs, all of the arc information. So let's just start plugging through and see what we can find. This is a central angle right here, angle AEB, central angle, which means that the arc is also 30 degrees. We have a 90-degree central angle here. That means arc BC is 90 degrees. And, oh, well, there's only one arc left. It's this big one out here, so we could add these guys together. 90 and 30 is 120, which leaves 360 minus 120, 240 for this mess out here. The measure of arc AB is 30. The measure of arc AC, just reading the diagram, 30 and 90 is 120. Measure of arc BC, 90. And the measure of arc ADC, 240. Done. That wasn't so bad. All right, now let's look at these guys down here. For 16, we have to find A, B, and C. All right, A, inscribed angle, half of its arc. So half of the 100 is going to make that A be a 50. B, inscribed angle, so half of its arc. Half of its arc is half of 110 or 55. And C, an interior angle. So that interior angle is 1/2 of its arc plus the arc of the vertical angle. 1/2 its arc is 110. Arc of the vertical angle 100. 1/2 of 210 is 105. Okay, one last one. 17. Oh boy. A, B, C. All right, I'm going to start off with A. It is an inscribed angle, so half of its arc, half of 110, 55. We have a diameter sitting right here. So all of that's 180 degrees. 110 up on the top, that means that this arc down here is 70. Angle B, then, inscribed angle, is going to be half of that 70, which is 35. Oh boy. Angle C, this C in here is tough. It's an inscribed angle, but we can't see where this hits on the other side over here. So what we're going to have to do is look at this angle down here. That angle is inscribed angle. It's going to be half of the 60, which is 30. Then this triangle, let's see if I can highlight it. This triangle, can you see that? Is isosceles, because that's a radius and that's a radius. That means the two base angles are congruent. So if that's 30, then that one's 30. Angle C is 30 degrees. Okay, thanks very much for coming. I hope that helps. Send me an email if you need some more explanation.